Software architecture is the foundational structure of a software system, defining its components, how they interact, and the principles that guide its design and development. It acts as a blueprint, helping developers organize, structure, and scale the system efficiently. At its core, software architecture focuses on both functional and non-functional requirements. The functional requirements describe what the system should do, while non-functional requirements address how well the system performs, such as in terms of scalability, security, maintainability, and performance. A good architecture balances these requirements while ensuring that the system can evolve as new needs arise. One of the key goals of software architecture is separation of concerns. This involves dividing the system into distinct, self-contained components or layers that focus on specific responsibilities, making the system easier to understand, develop, and maintain. Another crucial goal is scalability, ensuring the system can grow as usage increases or new features are added. It's also important to consider flexibility in the architecture, allowing for adjustments in response to changing requirements. Performance is another critical consideration, ensuring that the system can handle expected loads and deliver fast, responsive results. Finally, security is an essential factor, with the architecture helping to protect the system from unauthorized access and data breaches. There are several architectural styles, each suited to different types of software systems. Monolithic architecture is a traditional style where the entire system is built as a single unified application. It's straightforward and easier to develop in the early stages, but it can become cumbersome to maintain and scale as the system grows, particularly when dealing with large, complex applications. Microservices architecture, in contrast, breaks the system into smaller, independent services that communicate with each other. This design makes the system more flexible and scalable, as individual services can be updated or scaled independently. However, it also introduces complexity in managing multiple services, including handling communication between them and ensuring consistency across the system. Layered or N-tier architecture divides the system into distinct layers such as presentation business logic and data access. This separation makes the system more organized and easier to maintain because changes in one layer are less likely to affect others. While the layered approach is well suited for large, complex systems, it can introduce overhead due to the additional communication between layers. Event-driven architecture is another popular style where the system reacts to events or changes, often in real time. This approach is ideal for applications that require high responsiveness, such as e-commerce platforms or financial services, where actions must be processed immediately as they occur. Architectural patterns are recurring solutions to common design problems. The client-server pattern is one of the most well-known, where clients make requests to a server and the server responds. This pattern is widely used in applications like web browsing and database management. Event-driven architecture, as mentioned, is another common pattern, where systems are built around the detection and handling of events. Event-driven systems are particularly effective for applications that need real-time updates and can scale efficiently with demand. Ultimately, the role of software architecture is to provide a structured and reliable foundation for building and evolving a system. A well-designed architecture ensures that the system can meet current requirements, adapt to future needs, and be scalable, secure, and maintainable in the long term. By focusing on both technical and business goals, software architects play a critical role in ensuring that the system is not only functional, but also resilient, efficient, and easy to manage over time.